Okay, students, have a nice day once again. So, what we have discussed in the last class, just I am reminding you. In the last class, we have discussed about the line in space. So, we have discussed the distance of a point from a line, the image of a point with respect to a line, and also we have discussed if from one point to the line the perpendicular drawn, then what is the coordinate of the foot of the perpendicular, that we have discussed already. And simultaneously we have discussed the point of intersection between the two lines. As you know, if the shortest distance between the two lines is 0, of course we are telling the two lines are intersecting. And you know the shortest distance formula, A2 minus A1 dot B1 cross B2 divided by B1 cross B2 magnitude. If that shortest distance is coming 0, then the two lines are intersecting. But by knowing that, we cannot able to find out the point of intersection if suppose they are intersecting lines. So, that also we have discussed in the last class. If the two lines are intersecting, how we will able to understand whether they are intersecting or not? If intersecting, how we will find the point of intersection? So, dear students, all the concepts of the line is over. So, today we will come to the topic plane, that is the plane in space. So, you know something about the plane. As you know, three mutual perpendicular lines divide the space into 8 octants and their planes are coming out. And now we will discuss what is the equation of the plane, what is the all related terms of the plane. Then again we will see the point of intersection between the line and the plane, and how to mainly you will see here how to get the equation of the plane in different cases. And similarly, we will see the image of a point with respect to a plane, in which way we have done in for straight line, and a distance of a point from a plane, distance between the two parallel planes, in which way we have seen the distance between the two parallel lines, all those things we will see. So, before coming to that, let us think what's about the plane. So, what will be the equation of the plane? I am taking one small activity before you. You just see. And if you will see the room where you are sitting, let us think you are sitting the room in this floor. And this is one of the wall, this is one of the wall. Okay? I am thinking one corner of the room, and when this chapter will be coming out, you will just think about the corner of room. Why I am taking the corner of room? So, let us assume that this is the corner of the room and this is the x axis, suppose this is y axis, this is z axis. So, if this one, if it is x axis, it is y axis and it is z axis, I am showing, see, I have written x axis, y axis and z axis. Then you will tell me, this is, means this one is called xy plane, this is xy plane. And what you will tell this one? This one you will tell yz plane, and this is called the zx plane. So, these are the three planes we are finding here at the corner. This is also plane. My dear students, so if you take it is a plane, it's okay, it is a plane. First it is a plane. I am drawing one straight line on the plane. So this is the straight line on the plane, this is the straight line on the plane, be careful. We have already discussed the straight line in space. I am taking the straight line in the plane. If I will draw the straight line on xy plane, so what will be its equation? It will be, the standard equation will be ax plus by plus c is equal to 0. As you know, the equation of a line in xy plane, the standard equation will be ax plus by any constant is equal to 0. Suppose I am drawing one straight line on yz plane. This is the yz plane. You see, this is the yz plane. YZ plane, I am drawing one straight line. So, in YZ plane, what will happen? The equation will be something y, something z plus some constant is equal to 0. And similarly, if I will write in the zx plane, suppose zx plane, it is a straight line I am talking, zx plane. So, something x, something z plus something is 0. My dear students, I am writing the equation of the line. I am not writing the equation of the plane. Of course, these three lines equations what you are finding, they are lying on a plane. Because unless the plane, you cannot draw a line. So, this is the equation of the line on this plane. This is the equation of the line on this plane, this is the equation of the line on this plane. Okay, let us imagine yourself. I am talking about the line in xy plane. This is the line in xy plane. Okay, the equation is already x plus by plus c is equal to 0. Standard equation you know in the standard 11. Suppose, because you know, each and every point if you see on the line that x coordinate and y coordinate exists. Suppose each and every point will give to the z coordinates. What I am telling to say, the xy line, suppose you draw one line on the floor, on which floor you are sitting, and name this line is ax plus by plus c is equal to 0. As the line is drawn on the xy plane, each and every coordinate on the xy plane will show x comma y, some coordinate of x, some coordinate of y. What is my intention to say? Suppose to each and every point on the line which is lies on xy plane, I will provide one z coordinate. If I will provide one z coordinate, what will happen? This line will rise up. The line will rise. Suppose the line is here, the line will rise up. The line is rising up because the z coordinate is gaining. The line which was present on xy plane, each coordinate gain z coordinate. So, they have now three coordinates x, y, z. So, the line will not lie here. So, line will come up. Because the x, y, z coordinate is there. Because on this point, on this line, the z coordinate is 0. If the z coordinate will be other than 0, then the line will coming up. When this line is coming up, then you are finding a plane. So, this plane is created from the line by gaining z coordinate. So what should be the equation of the line, equation of this one? Because the equation of the line was a something x, something y, some constant is equal to 0. Now which coordinate it gain? It gain the coordinate of z coordinate. So what should be the equation of this plane? The equation of the plane, earlier it was x plus by, the line half. Now it gained z coordinate, then the constant will be there. So this will be the standard equation of a plane. In the same way I am telling the same way. This is the yz plane. This is the yz plane. This is the yz plane. And this is the line drawn on the yz plane. And each and every point on the line will reflect the y coordinate and z coordinate. So which coordinate is lack? Which coordinate is lack? That x coordinate is lack. If each and every point will be gained by x coordinate, then this type of wall will be created. And this is called a plane. So what was the equation of this yz plane? The yz plane, the equation was, or xy plane, yz plane, the equation was this one. Equation of the line was this one. Now it is gained x coordinate. So what will be converted? So I am giving x coordinate x plus by plus cz plus d is equal to 0. Similarly, the line on zx plane. So in the line on the zx plane, already each and every point will have the x coordinate and z coordinate. So what coordinate is it? Lack y coordinate. If I will give the y coordinate to it, it is also looking like this: x plus by plus cz plus d is equal to 0. So it is confirmed that if a line is on the plane, if the line is on the plane, suppose say you see this is the board, this is the board, this is the green board what you are finding, and this green board is on this plane. On this plane the green board is there, and you just see the edge of this board, this white portion you see, this is a line on this plane. Okay. So let us think it is x axis, it is y axis, it is z axis. So it is yz plane. This plane you are telling yz plane. So the equation of this line will be yz. In form of yz means the equation of the line will be this one: by plus cz plus d. This white one I am telling. And which coordinate is lack? X coordinates. If I will give the x coordinate to each and every point on this line, what the white line you are marking, so what will happen? One small floor will be created. One floor will be created, and that floor will be on, means just like a plywood. Just like a plywood, it will be created, and that will be that is called a plane. And ultimately, the equation of the plane will be this one. So, my dear students, you understand what will be the equation of the plane. What will be the equation of the plane? Understood? This is the extension of the line only. Extension of the equation of the line from one of the plane. If you will gain another coordinate which is lack it, then it becomes a plane. So the standard equation of the plane will be ax plus by plus cz plus d is equal to 0. So let us come to our mathematics. What this mathematics is telling? It is just the understanding what this mathematics is telling. So let us come to the mathematics. Now you see this is a plane. Suppose in case of line equation, you just remember passing through a point and a parallel to a vector. But in this case, suppose this is the plane and you just see this is the fixed point, I am holding it. I am holding the fixed point, and suppose I will take one line is parallel to it. Let this line is parallel to it, and this is the plane. And you see, just you see, if you will show like this without changing the position, without changing the position of the point and the position of the parallel vector, the position of the plane is changing. That means the plane passing through a point parallel to a vector, the position of the plane cannot be fixed. So, we cannot find the equation of the plane with this. So, what we will do? It is passing through a point and a perpendicular to a vector. Suppose it is passing through this point and a perpendicular to the vector. Passing through this point, particular this point and a perpendicular to the vector. You cannot change its position. Because if you change the position, so it cannot be perpendicular. If you change the position, the coordinate of this fixed point will be changed. So, the standard form of the equation of the plane, see, first write down the standard form of the equation of the plane. Write down the standard form of the equation of the plane. Standard form, I am writing the standard form. What is the requirement? Passes through the plane passes through a fixed point. Let the point is A with the position vector A vector, or A is a point with the coordinate x1, y1, z1. Correct? Let the line passes through the fixed point, that is capital A with the position vector small a or x1, y1, z1. The second requirement is perpendicular to a vector n vector, or I can say it is alpha I plus beta j or gamma k. Let be n vector is equal to this one. Let alpha I plus beta j plus gamma k is the n vector. So, let us come to here how to do the equation in the standard form. Let us think this is the equation of the plane. Correct? This is the equation of the plane. Let us think this is the equation of the plane. And let the plane is passes through the fixed point, say A vector. First I am considering the vector form. And no doubt I have to keep the locus point PR vector. And this is the vector which is perpendicular to the plane. So, once again I am telling the plane is passes through the point A with the position vector A vector. P is the fixed point locus, n vector is the perpendicular to it. If I will join these two, what I will get here? AP vector is equal to R vector minus A vector. And AP vector is on the plane. Say, suppose A is here and P is here on the plane. If I will join, then the AP vector is on the plane and this vector is your n vector. So, what is the relation between the n vector and AP vector? AP vector is perpendicular to the n vector. So, undoubtedly AP vector which is on the plane definitely perpendicular to n vector. So, that implies as dot product of both means R vector minus A vector dot n vector is equal to 0. So, R vector dot n vector minus A vector dot n vector is equal to 0. And students see R dot n, it is a scalar product. But within R vector x, y, z is there. X, y, z is there. Which will give the equation of the plane. So, A dot n is a pure constant or pure scalar. Okay, so I can write r dot n is equal to d, where a dot n is equal to d. Let means we are assuming. Let a dot n is the scalar that is equal to d. So r dot n is equal to d. This is the standard equation of the plane. R dot n vector is equal to d. This is the standard equation of the plane in vector form. In vector form, provided d is equal to a dot n, because we have taken one constant. You can take any other constant also. And now we want to convert it to the say Cartesian form. To the Cartesian form, just use r vector xi plus yj plus zk. Correct. N vector already I have given the name dot alpha I beta j gamma k is equal to d. So doing the dot product, what I am getting? Alpha I plus beta, alpha into x, alpha x into beta y gamma z is equal to d. So what we have called x plus by plus cz is equal to d. So in other ways, you mention something x plus something y plus something z is equal to a constant. That is the equation of the plane. That is the equation of the plane. So this is the vector form and this is the standard form. Okay. So I think you understand how it is coming. Requirement is passing through a point and perpendicular to vector, and by doing this process we got this one. This is the derivation of this one. Okay. So let us think, you already know the equation of the plane say something x, something y, something z. So if you analyze here, alpha x, beta y, gamma z is equal to d. So what is alpha beta gamma? Now alpha beta gamma is n vector, that is alpha I beta j gamma k. Now students, note down, in the equation of the plane, so the coefficient of xyz, the coefficient of xyz, coefficient of x is alpha, y is beta, z is gamma, is nothing, that is the direction ratio of the perpendicular vector, that is n vector. For example, for the plane, say 2x minus y plus 3z is equal to 6. The n vector obviously 2y coefficient of x minus j coefficient of y 3k, and a DRS of the perpendicular vector is obviously 2 minus 1 3. Understood? So take a small example for it, to that is the conversion of the equation of the plane from vector form to Cartesian form and a Cartesian form to vector form. Take one example. This is a one mark question asking sometimes. Reduce to vector form. A small question is asking, reduce to vector form. So 6x minus 2y plus 3z is equal to 6. So our standard form is r dot n. So x, y, z, that is equal to r vector. 6 minus 2 3, that is n vector. So r dot I can say 6i minus 2j plus 3k is equal to 6. So r dot n is equal to d. D is equal to a dot n. So r for x y z locus point, n vector coefficient of x y z, that is 6i minus 2j plus 3k is equal to 6. Okay. So this is the question to reduce the Cartesian form to the vector form. Similarly, the vector form to the Cartesian form. So this equation of the plane you understood, you just think the line when extended it becomes a plane. Okay. So this is the case. Okay, let us discuss another small problem based on the equation of the plane. Write down the second question. These are also one mark question also. Find the equation of the plane passes through, I am taking any point here, passes through 2, 1, 6 and a perpendicular to the vector, say I minus 2j plus 3k. Correct? I minus 2j plus 3k. So find the equation of the plane passes through the point this one and perpendicular to the vector this one. So you will get it. So what is given to us? The equation, if the point is given, the coordinate of the point is given, that is 2, 1, 6, and the perpendicular vector is given, that is I minus 2j plus 3k. So if I will convert to the position vector, so this is a vector is equal to 2i plus j plus 6k. Now equation of the plane r dot n is equal to a dot n. R dot n is equal to a dot n. Put r dot n, I am writing here. R dot n means xi plus yj plus zk dot, say n is already there. N is I minus 2j plus 3k is equal to a dot n. A is how much? 2i plus j plus 6k dot, say n is already there, I minus 2j plus 3k. So if we will dot do this one, so 1 into x minus 2 into y minus 2y, then 3 into z 3z is equal to 2 into 1 2, minus 2 into 1 minus 2, 6 into 3 18. So x minus 2y plus 3z is equal to 18. This is the equation of the plane passes through 2, 1, 6 and a perpendicular to the vector I minus 2j plus 3k. I minus 2j plus 3k. Actually what we are doing, that n vector is the coefficient of xyz. N vector is the coefficient of xyz. Instead of doing this one, we can write this one. So, only that 18 is coming from a dot n, that calculation we have to do. Otherwise, direct you can put the values, that is the coefficient of xyz will be the coefficient of the n vector, and a dot n is the d, which is coming 18 here. So, this is the standard equation of the plane. Simultaneously, we will discuss the another type of equation of the plane, that is the second one is called the normal form of the equation of the plane. So, let us write down the normal form. So, today we will discuss the standard form and normal form. The next class will go inside the plane, inside the plane chapter, then we will do so. And before that I should mention that the pi is denoted for plane. In which way we are writing? The line is L1, L2, L3. Similarly, pi 1, pi 2, pi 3, pi 4. These are the symbol given to the plane equation. Okay. Now I am discussing about the normal form. Normal form. So, before coming to the normal form, I am just reminding you the normal form what you know in straight line in class 11. And what do you mean by the normal? So, normal is the distance of the the distance of the plane from the origin is called the normal. In the class 11, distance of a line from the origin was called the normal. So, here the same thing, that is the distance of the plane from the origin is called the normal. So, in the normal form what will be given? In this form what will be given? The normal given. I already told normal suppose P is given, normal P is given. Then what is the second thing is given? The unit vector along the normal. Unit vector along the normal n cap, that is given. Then see how to find the equation of the plane, that is called the normal form. Okay, I am taking one plane. So, this is the plane. Let this is the origin 0, 0, 0. Distance of the plane from the origin, say OA. So, obviously OA distance is P, because that is called the normal. And along this n cap is given, unit vector along this. So, once again I am telling the given was normal P, unit vector along the normal, that is n cap given, P given, n cap given. And be sure one locus point is there permanent. Now again you join this one. Now AP vector come out. So, here AP vector coming out once again, and AP vector, and you see OA vector or AO vector. So, AO vector, the distance is P and the direction is n cap. So, obviously AO vector will be P n cap, because this is the magnitude, this is the direction, correct? And though AO vector is a vector starting from the origin, then we will tell it is a position vector. Position of which point? Now, position of the point O is already there. So, obviously it is the position of the point A. So, the position of the point A is undoubtedly P n cap, correct? The P was given, n cap is there. So, magnitude and vector, magnitude and direction, that becomes a vector. AO is a position vector. Okay. So, if this one happens, or I can write also AO or OA, whatever you want to set. and OA also I can write because starting from the origin, no issue for that. Now, AP vector and OA vector, AP vector and OA vector obviously perpendicular to each other. So, their dot product will be 0. So, AP vector R vector minus A vector, A is not there, R minus P n cap, R minus P n cap is equal to R minus P n cap dot OA vector is already P n cap 0. Once again, AP vector R minus P n cap perpendicular to OA is already P n cap. So, do the dot product, R dot P n cap minus P into P square, then n cap dot n cap is 1 is equal to 0. So, that is equal to R dot P n cap is equal to P square. Cancelling, I am cancelling because P is a positive quantity. So, what I am getting, R dot n cap is equal to P. This is the equation of the plane in normal form. It is very interesting. It is very interesting because if I compare, then you can able to understand how it is interesting. So, once again I am taking, so the normal form equation is R dot n cap is equal to P, and the standard form R dot n vector is equal to D. Compare this both. This is the normal form. This is the standard form. So, what is common? R vector is common. It is n vector, it is n cap. That means, in the n vector, if this vector will be the unit vector, so simultaneously that D will be the normal. Once again, if the standard equation of a plane is given, and if you will able to convert this one to the vector form, so what you will get? You will get R dot n vector, and if you will make this n vector as a unit vector, means by dividing its magnitude both sides. So, I can say D divided by magnitude of n vector is equal to P, because if I will do R vector, how I will make it? Now, n vector by n vector magnitude. So, it will be D by n vector magnitude. So, that is nothing, that is your normal. So, conversion of the standard form to the normal form, we can do it only making the and if the normal form is there, you will get the normal. So, what is the normal? The distance of a plane from the origin. I am taking a question on it, small question I am taking on it, very small question, it may be 2 marks question. Write down this question. Find the distance of the plane 2x minus 2y plus z is equal to 9 from the origin. Write down the question, write down and realize. Find the distance of the plane. This is the plane from the origin. So, distance of the plane from the origin is nothing, that is normal, that is P. So, let us convert this equation to the standard form. Already we know that the equation the equation of the plane r dot n vector coefficient of x y z 2i minus 2j plus k is equal to 9. So, my dear students, you see this equation is of this type r, this is your n vector and d is equal to 9 here. So, how will convert it? Now, I will make it n vector to n cap, n vector to n cap. So, I have to divide the magnitude of this. So, let us see what is the magnitude. 2 square 4 minus 2 square is 4, 4 plus 4 8 plus 1 9, root over of 9, root over 9 is 3 by 3. I am directly doing by 3. So, what will happen? So, r dot 2 by 3 I minus 2 by 3 j plus 1 by 3 k is equal to 3. So, now it is in the form of r dot n cap is equal to p. Now, it is the form I can write here, it is in the form, it is in the form r dot n cap is equal to p. So, what is the value of p? So, here p is equal to 3. Then what is p? The distance of the plane from the origin. So, finally you can write, therefore, the distance of the plane from the origin is 3 units. So, I only converted the standard form to the normal form. Simultaneously, I am taking the same question. But in the same question but another bit 2 same question. First one, the distance of the plane from the origin. Second, the coordinate of foot of the perpendicular drawn from the origin. So, you just observe 1 minute, you can understand. So, I am drawing the figure. The origin was here 0 0 0 and it was p already A, and you know this is the p n cap. So, the point A is the foot of the perpendicular. And the coordinate of it is p n cap. So, directly by using this concept, I can write the solution directly. Your answer is p n cap. What is the value of p? 3. N cap how much? 2 by 3 I. 2 by 3 I minus 2 by 3 j plus 1 by 3 k. So, cancelling. So, what will come? 3 3 cancelling, that is coming 2 minus 2 1. 2 minus 2 1 is this one. Correct? 2 minus 2 1, this is the foot of the perpendicular drawn from the origin to this, and fortunately this point and this point is coinciding, p n cap. So, my dear students, today we have discussed about the standard form and the normal form. Standard form r dot n vector is equal to d is equal to a dot n, r dot n cap is equal to p is the normal, the distance of the plane from the origin. So, we are assigning some assignment to you. So, hope you will finish. So, thank you for your patience. Thanks all.